All right, welcome back. Okay, so looks like people are still coming in, but anyway, I think since you're the one who asked about this problem, we can continue. So you know how to solve for k from here, right?
Yeah,
Yes.
you just need to do
Mhm.
8,000 times 4, which is 32,000.
Right. So let's 32,000, and then now we can rewrite our equation things. So we have our relationship. So I equals 32,000 times 1 over d squared. And then I think the problem, all right, it says, what will the intensity be at a distance of 7 miles? So all we have to do is solve for I one more time because here the distance is 7 miles. So what would go on the bottom?
Four.
Okay, so in the question it says, what will the intensity be at a distance of 7 miles? So it's given us a new distance.
Oh, I thought it was 2.
Okay, but that was when the intensity was 8,000 units, but it's asking us to
Oh,
find the new intensity when the distance is 7. So
Wait, what is this?
we already found the intensity when the distance was 2, but now we have to find the intensity when the distance is 7. Yes.
wait, so it's 7 square, but do we
Right.
change it into 49?
Sure.
Okay.
So all we have to do now is do 32,000 times 1 over 49. So we just solve for I, and I think we should get around 653 if we do this about, I think. Yeah, we get around 653 units, so that's how we do that one. So number 22, the answer should be B. Okay, does that one make sense?
Yes.
Okay, cool. Are there any other questions?
Question 26.
Was that 26?
Yes.
Okay. All right, so it says the volume V of a given mass of gas varies directly as the temperature T and inversely as the pressure P. All right, and it gives us these three numbers, and then it's asking what is the volume when T is 360 degrees and P is 10 pounds per inches squared. All right, cool. So how would we write this relationship? So first of all, we know V is directly proportional to T, so let's write it like that. So how would we write it?
KT.
Exactly, it would just be KT. And if V is inversely proportional to P, how would we write that?
1 over P.
Right, K times 1 over P. Basically, all you have to do is combine these. So what we pretty much get, it's kind of like before the first problem you were asking about with like jointly, varies jointly. It's pretty much combining both these relationships to get something like V equals K times T over P. So basically it's just, it's like K times T times 1 over P. Does that make sense? All right, so for anyone just entering, we're doing number 26.
Oh yeah, I understand.
All right, cool. Does it make sense, Jay?
Yes.
Okay, cool. So now we're given this information. So we're given the volume, we're given the temperature, and we're given the pressure. So we can solve for K if we know all three of these, right? So can you rewrite this expression replacing all the V's and the T's and the P's with the numbers we're given?
480 equals K times 320 degrees
Mhm.
times 1 over 10
All right.
square.
Wait, oh,
Oh, okay, never mind.
so yeah, this one, in this case, it would be just 10 because in our relationship, it said that it didn't say that volume was inversely proportional to the square of pressure. It was just pressure. So that's why it's just P in this case. So we don't have to square anything. And then all we have to do is solve for K. So we can always do this, right? So we just have 32K is 480. So all I did was, divide this by 10. So it's 32. And then we can solve for K. And we can plug this number back into this. So what we get is 480 over 32 times our new temperature, which is 360 degrees, and our new pressure, which is 10 pounds per inches squared. And then all we have to do is this. And we should get 6 over 32. All right, I think we should get 540. And we can't forget the units, so it's around inches cubed. So that's how we get our new volume, number 26. So I think that's why the answer is D, 540 inches cubed.
Yeah, it's that.
So does that make sense?
Yes.
All right, cool. Are there any other questions we can go over?
I don't have
Yeah,
I don't
you
have
do.
any more questions.
Oh, okay, cool. Are there any questions from anyone else about the homework or any topics we can go over?
No, not really. But how do you see the recording of this?
Oh, I'm gonna upload it on a YouTube channel and I can send you the link if that works.
Okay.
All right, cool. You guys are good with the what is this? Parallel intersecting lines and stuff? Yeah. Okay, good to know.
Oh wait, how can you tell if something was is an ordered pair of the solution or whatever? Like 29 and 30?
Okay, so it says,
Wait, not 29 and 30. I mean 31 through 33. Like, how do you do that again? How do you find that out? The parallel
or-
intersecting the one that you were talking about.
oh, okay, so let's see, let me try looking for it. 31. Okay, so how can we tell if a pair of lines is parallel? What do we know about the slope if two lines are parallel?
They never meet.
Yeah, so they never meet. So what does that tell us about the slopes?
They rise at the same angle, or they're at the same angle.
So it just tells us that the slopes are exactly the same.
Yeah.
So knowing that, you can do the problems. So all you have to do is find the slopes and see if they're the same or not, and then yeah. So can you rewrite this in the form of y equals like mx plus b? So can you rewrite it so that we have y on one side?
Yeah, it's
Mhm.
wait, so first you do 4y equals negative x plus 17.
Right.
Divide both sides by 4.
Uh-huh.
Wait, so is
The
it
left side becomes
4y?
y, and then the right side becomes negative 1 4 x plus 17 4.
Yeah, perfect.
Okay, I understand it now.
Okay. And then let's just do the other one. So uh Ryan, can you go over this one?
5x minus y equals 7. It's negative 6y equals 7 minus 5x.
Uh-huh.
And then, hold on, divide that. Wait, can it be 6y and then equals 5x minus 7?
Yeah, exactly. Or we could, do it in one step. So just divide both sides by -6.
Wouldn't that be a
So if we divide both sides by -6, all we, get is y equals 5,
yeah,
6
isn't it repeating this? Oh, never mind.
minus 7, 6.
I tried to divide using decimals.
Oh, I see. Oh, well, you could do that too, I guess. I don't know.
Yeah, but then
Anyways,
it's repeating.
huh?
Then it's repeating.
What's repeating?
If you divide it using decimals, it's a repeating decimal.
Uh-huh. Oh, okay then. Um, but yeah, you can just leave it like this and okay, so now we know the slopes. So what are the slopes?
They're
Ryan, what's the
intersecting,
slope?
not
For this
parallel.
one? Huh?
They're intersecting.
Yeah. So what's the slope of the top one?
It's going down.
So do you know how to do you know how to tell this? Oh my God. 1 second. Okay, do you know how to tell the slope from just looking at a line?
The x, if it's negative or positive,
Okay, so if we have something of the form y equals mx plus b, what is the slope? Is y the slope? Is m the slope? Is x the slope? Is b the slope?
isn't it mx?
Okay, so x and y, those are just variables that we're relating. So okay, so before when we were talking about these sorts of problems, you said you understood how to do it, right? when we had like this kind of problem. So we were just relating v, t, and p, but the thing that told us, by how much was k, our constant. That was like kind of like a slope. In this case, m is the slope because that's what, tells us the extent of the relationship between y and x. The slope is what tells us, how is it a positive? Is it minus? Does it go straight up? Does it go like this? That's everything that the slope tells us, and it's really important. So the slope is always the coefficient in front of x, and that's why we always write it like this, in this form, y equals mx plus b. So m is the slope.
Okay.
Do you know what b is?
B is the starting point of x, right? It's like 0, the y-intercept.
Yeah, it's the y-intercept. It's whenever x is 0. All right, so yeah, just make sure you know that this is the slope, this is the y-intercept.
Okay.
All right, so in the end, since the slopes aren't the same, then they're going to intersect at some point. Okay. Does that make sense?
Yeah.
All right, cool. Are there any other questions we can go over?
You're muted.
Yeah, I was just wondering if there were any questions.
Oh, no, I don't have any more.
All right. Okay, any last questions in the last 5 or so minutes? All right, if there aren't any other questions, then you're free to leave and have, a great rest of your day. Oh, enjoy your 4th of July.
Okay, thank you.
And
Um,
bye.
Bye.
We have homework on 4th of July week.
Um, uh, was anything said about it in class?
No, wait, I'm
I
not
had a
really sure.
test today.
Oh, yeah.
Oh, okay.
Wait,
Sorry,
there's
I'm not too sure. You might have to check with teacher and stuff, your teachers.
Okay.
All right. Have a
Bye.
great 4th of July. Bye.
Bye, thank you.
No problem.